The vast tapestry of the cosmos woven with billions upon billions of galaxies, each home to countless stars. As we stare into the inky blackness, a question echoes through the void, a question as old as humanity's capacity for wonder. Are we alone? For centuries this query has been a whisper in the dark, a profound yearning. But what if the silence isn't just a lack of answers, but an answer itself? What if the universe is not just empty but eerily quiet? Welcome to Unknown Frequency, where we explore the most enigmatic questions of existence. Tonight we plunge into the heart of the greatest cosmic riddle, the Fermi Paradox. Where is everyone? The Fermi Paradox, named after the brilliant physicist Enrico Fermi, is a chilling contradiction. On one hand, the sheer scale of the universe coupled with the laws of probability suggests that life, intelligent life, should be abundant. The conditions for life are not unique to Earth, they are scattered across the stars. Yet, despite our relentless searching, despite advanced telescopes and radio antennae straining to catch a whisper, we have found nothing. A profound echoing silence. It's a cosmic paradox that rattles the very foundations of our understanding. Consider the numbers. Our own Milky Way galaxy alone is estimated to contain between 100 to 400 billion stars, and astronomers now believe that most, if not all, of these stars host planets. The Kepler Space Telescope, in its brief mission, revealed that rocky Earth-sized planets are incredibly common, with many orbiting within their star's habitable zone, the Goldilocks zone, where liquid water could exist if even a tiny fraction of these planets harbored life. The universe should be teeming with it. Civilizations should have risen, spread, and left their indelible mark across the cosmos. This idea was famously formalized by the Drake equation, a probabilistic argument that attempts to estimate the number of active communicative extraterrestrial civilizations in the Milky Way. While its variables are largely speculative, even conservative estimates suggest that there could be thousands, even millions of intelligent civilizations in our galaxy alone, civilizations that could be sending out signals, building colossal megastructures, or launching interstellar probes. So if the numbers point to a universe bursting with life, why haven't we heard a single sound? Why is the cosmos so utterly disarmingly quiet? This then is the heart of the great silence, a silence so profound it becomes deafening. No alien mega-engineering projects, no Dyson spheres around distant suns, no probes observing us from the outer solar system, no stray radio transmissions from a civilization light years away. For all our searching, for all our growing technological prowess, humanity remains an isolated beacon in an ocean of darkness. It forces us to confront unsettling possibilities, each more thought-provoking than the last, about our place in the universe and the ultimate fate of intelligent life. One explanation suggests that Earth itself might be an anomaly. This is the rare Earth hypothesis. It argues that while simple life might be common, the precise confluence of factors required for complex intelligent life to evolve is exceedingly rare. Consider the perfect size and composition of Earth, its stable orbit, the presence of a large moon stabilizing its tilt, a protective magnetic field, the right kind of star, and its position in the galaxy away from harmful radiation. Perhaps we are not just lucky but astronomically uniquely lucky, a cosmic fluke. But perhaps the most chilling explanation for the great silence is the concept of the great filter. This theory posits that somewhere along the evolutionary path from the first single-celled organisms to a spacefaring multiplanetary civilization, there exists a profound, almost insurmountable barrier, a filter that prevents life from progressing beyond a certain point. The critical question then becomes, where is this filter located behind us? Meaning we are a rare exception that made it through, or more terrifyingly, ahead of us. If the great filter is behind us, it means humanity has already overcome it. This suggests that the emergence of life itself is extraordinarily rare. Perhaps the jump from non-living matter to self-replicating organisms is far more improbable than we imagine, or maybe the transition from simple prokaryotic cells to complex eukaryotic cells, which allowed for multicellularity, is the truly rare event. Scientists refer to these as abiogenesis and eukaryogenesis. The universe might be full of planets with the raw ingredients, but few ever get to simmer into life. Consider this shocking scientific fact: the transition from single-celled organisms to multicellular life took billions of years on Earth, and it appears to have happened only once, giving rise to all plants, animals, and fungi. This singular, incredibly complex leap, the ability for cells to cooperate, specialize, and form intricate structures, is not a given. What if the emergence of complex differentiated life is the true filter, a cosmic lottery that very few win? If that's the case, then intelligence, let alone advanced civilization, would be an even rarer cosmic diamond. But what if the great filter lies ahead? This is a far more terrifying prospect. If intelligent life frequently arises but then consistently fails to overcome a final catastrophic hurdle, it means our future might be predetermined. This late-stage filter could be anything: self-annihilation through nuclear war, irreversible climate catastrophe, a runaway artificial intelligence, a synthetic plague, or the depletion of critical planetary resources. Many civilizations might reach a certain technological level only to succumb to their own destructive capabilities or the unintended consequences of their advancements. Then there's the dark forest hypothesis, born from Chinese science fiction. It suggests that the cosmos is a perilous place, like a dark forest where hunters hide. Any civilization that broadcasts its presence risks attracting unwanted attention from more powerful, potentially hostile entities. Therefore, the safest strategy for any intelligent species is to remain utterly silent, to hide, and perhaps even to preemptively eliminate any nascent civilizations that might pose a future threat in this cosmic scenario. The silence is not empty but a sign of universal fear and extreme caution. The zoo hypothesis offers a less grim but equally humbling explanation. What if extraterrestrial civilizations have indeed discovered us but have chosen not to interfere? Perhaps they view us as a protected species in a cosmic nature preserve, a fledgling civilization not yet ready for contact with the broader galactic community. Our lack of contact wouldn't mean we're alone, but rather that we're being deliberately, carefully observed, waiting for the moment we pass some unspoken galactic maturity test. We are in essence the subjects of a cosmic anthropological study. Another possibility is that alien civilizations are simply too advanced for us to recognize their technology. Their very existence might transcend our current understanding of physics and biology. Perhaps they communicate through entangled particles, manipulate spacetime, or exist in forms we can't even begin to detect with our current instruments. Their signals might not be radio waves but rather gravitational ripples, quantum fluctuations, or even entire simulated realities. To look for them with our current methods might be like an ant trying to understand a supercomputer. Then there is the daunting yet hopeful possibility that we are simply among the very first. The universe is still young, only 13.8 billion years old. Perhaps the conditions for complex life and intelligence have only recently become widespread enough for civilizations to emerge. If this is the case, humanity stands at the very forefront of cosmic evolution, a pioneer species gazing into a future that we alone for now are destined to forge. It's a heavy burden but also an incredible opportunity. And what if the ultimate answer is closer and stranger than we could ever imagine? The simulation hypothesis posits that our entire universe, our reality, everything we perceive, is merely a sophisticated computer simulation. If this were true, the aliens might simply be other programs or entities outside of our simulated environment, or perhaps the simulation is designed to run without other intelligent life for specific reasons. It's a thought that challenges our very definition of existence and could explain the silence in a way we've only ever dreamt about in science fiction. Despite the daunting questions, humanity's quest for answers continues. Projects like SETI, the search for extraterrestrial intelligence, continue to scan the skies, listening for any sign of a signal. New generations of telescopes like the James Webb Space Telescope peer deeper into the past and analyze the atmospheres of exoplanets for biosignatures, chemical hints of life. Our exploration of Mars and other moons in our solar system seeks to uncover simpler forms of life. The silence may persist, but our determination to understand it only grows stronger. The Fermi Paradox isn't just about whether we are alone. It's a profound mirror reflecting our own aspirations and fears. It forces us to consider the fragility of life, the challenges of technological advancement, and the ultimate destiny of intelligent species. The great silence compels us to look inward, to ponder our own choices, and to safeguard the one confirmed oasis of life we know. Whether the universe is empty, dangerous, or simply waiting, the implications for our future are immense. The silence continues to stretch across the cosmic expanse, challenging our assumptions and fueling our imagination. Does it signify our unique importance, a terrifying future, or a grand cosmic secret beyond our current grasp? What do you believe is the most compelling explanation for the great silence? Is the great filter behind us, or are we hurtling towards it? Share your theories, your hopes, and your fears in the comments below, and if you dare to journey further into the unknown, be sure to subscribe to Unknown Frequency for more explorations of the universe's deepest mysteries. Until next time, keep looking up and keep questioning everything.